section 5.5?
This is section 5.5, yes. We are solving absolute value inequalities. You guys have solved absolute value equations. We did that earlier this year. How many equations did we solve when we solved absolute value equations? Two. We've done lots of review problems on tests and quizzes, haven't we? For absolute value equations. We are solving absolute value inequalities today. So we're going to put what we know about absolute value equations and what we know about compound inequalities together, and we're going to solve absolute value inequalities. Today, all of the problems, all of them are going to be and. And there's an easy way for you to tell that these are all and. Well, no, actually, it won't say anything today. It won't say and or. But they're all going to have this symbol. What symbol is that? Less than. Here's how I remember. I know, that's not how you spell than. But think of it this way, less than is an and. So if our problem has a less than symbol or less than or equal to, it is going to be an and compound inequality. They're not going to tell you today that it's an and or an or. You're going to have to recognize that, oh, they have a less than symbol, so it must be an and. They have less than or equal to symbol, so it must be an and. Okay, so less than is an easy way to remember. Because what's going to happen Monday? I'm going to give you greater than. What do you think greater than is going to be? Great or than. Okay, it'll be an or. So just as something silly to help you remember. So if you see less than, it is and. Less than is and. All right, so let me go back up here to the top. You don't need to write this down. I just want you to listen. It says when solving absolute value inequalities, there are two cases to consider. The expressions inside absolute value is non-negative, normally called a positive. And two, the expression inside the absolute value is negative. We're going to have to consider both cases, just like when we solve absolute value, we solve absolute value equations. We had to set up two, didn't we? We had to consider both cases, that what's inside the absolute value could be positive or negative. So we're going to solve two inequalities. We're still going to graph these ands. So let's look at an example of what we're looking at. Here's the first one. I'm going to start off easy for you. The absolute value of x is less than 7. The absolute value of x is less than 7. Those absolute value bars should be a dead giveaway that something is different, right? We're not just solving a basic inequality. Those absolute value bars tell us we solve 2. When we set up our inequalities, the first inequality is going to be x is less than 7. The second inequality is going to be x is greater than negative 7. Now I'm also going to write the word and in here. How again did I know this was an and? The original symbol is less than. Tells us it is an and. Now the first inequality looks almost identical to the original inequality, doesn't it? The second inequality has a couple of things that are different. Can someone raise their hand and tell me one thing that's different? Haley. The 7 is a negative. Jess, what's another thing? The inequality symbol is flipped, and that's going to happen every single time. Do you guys remember when we learned that if you multiply by a negative, you flip your symbol? Essentially, that's what we're doing on the right side. We're multiplying by a negative 1. Well, when we multiply by a negative 1, what happens to our symbol? We flip it. So we need to set up our two inequalities. The second one's always going to have the opposite symbol and the opposite sign. There's no solving to be done here. So let's set up a number line and graph these two. I'm going to make my number line go by 7. You can make it go however you want. I want to graph numbers that are less than 7 and greater than negative 7. Right now on your paper, I want you to graph those numbers. Graph numbers less than 7 and greater than negative 7. Remember, it has to satisfy both. You're looking for all the numbers that work for both of those inequalities. very good, guys. I think you guys are really getting the hang of this already. Agree, we should have open circles at -7 and 7, and our graph should connect those two open circles. Okay, so the next thing we need to do is write a compound inequality. We need to write an inequality that describes what our graph is sharing with us. Our graph is saying that our solutions are between -7 and 7. Remember, we write a compound inequality a special way to show that. We're going to say that our variable x is between -7 and 7. Our variable x is between -7 and 7. So pick a value between -7 and 7.
0, 0.
0 would be perfect. Is -7 greater than 0? Or is -7 less than 0? Is it? Is -7 bigger than 0? Less than. Is 0 greater than 7? Or is 0 less than 7?
Less than.
Less than. Now,
how do you know to ask it that way? Could you ask for 7?
We always read from left to right. Could any of our solutions be equal to -7 or equal to 7?
No.
No, we have open circles here, and that came from these inequality symbols here. So that's our solution. Just like we did previously, we need a graph and we need a compound inequality. We need both of these guys. Let's try another one. We're actually going to have to do some solving. So the absolute value of m plus 2 is less than 11. First of all, is this an and or an or? And. What part of this indicates or tells us that it's going to be an and? Less than is and. So let's set up our two inequalities. The first one's going to be m plus 2 is less than 11. Remember, the first one looks exactly like the original problem. And m plus 2 is greater than -11. Remember, we're going to change two things. We changed our number, made it -11. Essentially, that's like multiplying by a -1. When we multiply by a negative number, we're flipping our symbol. Change your sign and your symbol. So let's solve both of these inequalities. This side I'll subtract 2. M is less than 9. On the right side, I'll also subtract 2. M is greater than -13. When you got your number lines wrong, go ahead and show or graph numbers that are less than 9 and numbers that are greater than -13. Remember, it has to satisfy both of those conditions. Numbers that are less than 9 and also greater than -13. Has to satisfy both. Now, when you're doing your number lines, just a reminder to make sure your negatives are on the left side, your positive numbers are on the right side. Make sure you're going by equal increments when you increase. I don't care if you go every odd number or if you go every third number. It doesn't matter to me what you go by as long as you're going by equal values. So your graph, looks like you guys are on the right track with your graphs. It's between -13 and +9. This guy, make a more onto the 13. So did you write your compound inequality also? Did you go ahead and do that step? between two numbers. They're between negative 13 and negative 9.
Could you start with 9 and then 13?
Good question. I do want you to start with a smaller number. When we're writing our compound inequality, we'll start with our smaller number, which is negative 13. So if we pick a number that falls between negative 13 and 9, I'm going to think 0. Easy to think about. Is negative 13 greater than 0? Or is negative 13 less than 0? Less than. Is 0 greater than 9? Or is 0 less than 9? Less than. Now think about your solutions. Could any of your solutions here on your number line be equal to negative 13?
No.
No, we have an open circle at negative 13. So not equal to there. Could any of our solutions be equal to 9? No. We have an open circle. So once again, we need two things. We need the graph. And the compound inequality. Let's look at this one. The absolute value of y minus 1 is less than negative 2. How do we know this is going to be an and, other than I told you they're all going to be ands? What tells us that? Less than is and. So let's set up our two inequalities. Y minus 1 is less than negative, not equal to, excuse me. Less than negative 2, and y minus 1 is greater than positive 2. So let's go ahead and solve. We'll add 1 to both sides on the left side. Y is less than negative 1. On the right side, we also should add 1. Y is greater than 3. I would like for you to graph numbers that are less than negative 1 and numbers that are greater than 3. Numbers that are less than negative 1 and greater than negative 3. I'm going to separate the class into two groups. I don't want you to talk. I just want you to move when I ask you to move, okay? I want you to go over there. I want you to go over there. I want you to go over there. I want you to go over by the door. I want you to go over by the door. You can take your algebra with you, please. You can just take your page and you got it. Go by the door. I want you to go over here. I want you to go over by the door. I want you to go over by the door.
You went wrong and right.
Shelf. Door. Shelf. No, door. Ah, door. Shelf.
You got it wrong.
Shelf. Door. Yes, door.
Woohoo!
Let's give you. Door. Door.
Y'all wrong.
All right. Somebody's right and somebody's wrong, and I'm not going to tell you who is who.
We're right.
Look at you guys. Look at all your answers. Do you all have the same answer?
Y'all wrong.
Do you guys all have the same
You're
answer?
wrong.
Should. I think if I did it right.
Yeah, you just told us we're right.
I didn't tell you were right.
We all should have the same answer.
Always go the
You guys
right
might
way.
be right.
The right way is wrong.
Okay. Now I want you guys to partner up with these guys. Get over there with those guys.
Yes.
Look at their
No, go away.
answers. Look at their answers.
I'm so much cheating.
You're wrong.
You
We were right. We were right. We were right.
Less than negative 1 goes out.
When somebody thinks that they know who is right, raise your hand. But I want to know why. I want to know why.
Right.
Cameron, do you know why? Well, who's right?
I was.
No.
This side door
I
people
was.
are
This side.
You're wrong.
door, okay?
Cameras
Or
can't
it's
be
not
numbers
right.
between negative
Oh,
one
she said
You was wrong.
Shelves, you were wrong. Doors were the right ones.
I can
Before you sit down, somebody's gonna tell me why. Why were the door people right? Preston, hang on, listen, guys, you listen.
They can't be numbers between negative 1 or 3.
Did you guys hear what he said? Shh. Preston, I'm sorry, say that one more time.
They can't be negative 1, 3, or any number in between negative 1 or 3.
Think about what he says, guys. They're not numbers between -1 and 3. This is saying numbers less than -1, right? This is saying numbers greater than 3. If we draw,
Can't see.
this graph, is that showing numbers less than -1? Is that showing numbers greater than 3? Have a seat real quick. Have a seat.
No. Bad.
Hey guys, let's not use that kind of language.
I'm happy. I won.
Everybody, yeah.
Okay, so let's think about how we're going to write this answer.
Oh, it
Instead of less than -1, instead of greater than -1, it needs to be less than -1. Greater than 3. Okay. Now, it's and, right? I want to know what numbers are less than -1 and greater than 3. Give me one number that's less than -1 and greater than 3. No, 9 is not.
no numbers.
Oh, none. I thought you said 9. None. There are no numbers, are there? If something is less than -1, it can't be greater than 3. So what are we going to say? No solution. And now it's not all numbers because we don't have any of them that are solutions.
0 slash.
0 at the line through. Now, this graph would not work for me. This graph says that your solutions are less than -1 and greater than 3. That's not true, is it?
Yeah.
No, there are no numbers that are less than -1 and greater than 3. You need to erase the lines that you drew. You need to erase the lines that you drew.
So no one got it right.
You need to erase the lines that you drew.
Uh-oh.
Your graph should be empty. There are no solutions. Didn't we just state that? Okay, so don't put anything on your number line. If you put something on your number line, that's stating that the solutions are here. If there aren't any solutions, you should have a blank number line. Now, I tried to do this one was going to be a little funny from the very beginning. Does anybody know how I knew that? Haley? It started with a negative. And we had to change from a negative to positive, and we hadn't done that before. Kind of keep that in mind. That may be a key for you.
So if God starts with a negative, it's no solution.
I'm not going to say that. No, I'm not going to say it's always going to be no solution. But I want you to look for those patterns. You're thinking that it possibly could be a no solution. Let's look at this one. The absolute value of 2c minus 5 is less than -3. Is this an and or an or? It's and. How do I know it's an and? Less than. So let's set up our two inequalities. 2c minus 5 is less than -3, and 2c minus 5 is greater than a +3. So let's solve. Add 5. 2c is less than 2. So divide by 2. C is less than 1. The right side will add 5. 2c is greater than 8. Divide by 2. C is greater than 4. I want you to graph numbers that are less than 1 and greater than 4. Graph numbers less than 1 and greater than 4.
You can't write that one.
What less than 1 and greater than 4? There isn't. If something's smaller than 1, it's not going to be greater than 4, is it?
After then you
So when your graph goes two different ways, it's no solution.
On an and. On an and, if your graph goes in 2 different directions, opposite directions we'll say, then it would be no solution. Remember, don't put anything on your number line if it is a no solution, because if you have something on there, then it says, this is the solution. So you guys are starting to notice some patterns, right? Got these negatives? Math is all about patterns. It's all about recognizing little things that will make a huge impact on your
So if I'm
answers.
right about the name,
Not always, most of the time. I don't want to say always because when we get to ors, it's not the case.
I mean, not and.
But,
But I still need you to show your work. To show me your work.
So you're gonna ask me.
To answer your question, yes, you have to show your work. You can't just say no solution. Because I knew that's where it was going. Okay, I am going to stop here for today. I have some problems for you guys to practice on solving absolute value inequalities. Page 312, 1 through 3, 8 through 13, 22, 23, 25, 27, 29.